Hi, everybody. So we're talking about Newton's three laws, right? And Newton's first law is going to tell us about inertia, which means that objects in motion want to remain in motion. Things that are moving want to stay moving. And objects at rest want to remain at rest. They want to stay not moving until these objects are acted on by an outside net force, right? Something has to push them or pull them to accelerate them, right? Everything that accelerates gets there by something pushing or pulling it. And Newton's first law tells us about inertia. His third law tells us that for every action, there's an equal and opposite reaction. Those are the force pairs. We know how that works. And Newton's second law is what I want to show you right now. This gives us our equation, right? That relates force to the two things that matter, an object's mass and its acceleration, how much it's going to accelerate by once its force acts on it, right? So this is the equation, and look how simple this is. Force is equal to an object's mass times its acceleration, and that's it. It doesn't get harder than that. F is equal to ma. That's Newton's second law. Force is equal to mass times acceleration. What does this tell us? It tells us that the force that's required to accelerate something is equal to its mass times that acceleration, right? So let's practice with this. So if I have a mass of, let's say, 2 kilograms, and I want to accelerate something at 5 meters per second, that's 2 times 5. 2 times 5 is equal to 10. So this tells me I need 10 newtons of force, because it's named after Isaac Newton, to accelerate a 5 kilogram object at 2 kilogram object at 5 meters per second squared, right? So what if that object had more mass? Do you think the force would need to go up or down to move it at 5 meters per second squared? Of course it would have to go up. So let's talk about that. What if the object was more massive? 4 kilograms. What is 4 times 5? 4 kilograms times 5 meters per second is going to equal 20 newtons. I need to double the amount of force, right? If I double the mass, I need to use twice as much force, right? And I could do other things with this too, right? I can say, what if I had a 10 kilogram object? How fast would it accelerate? A, if I use 20 newtons, right? Now I have this A here and I don't know it. 20 newtons is equal to 10 times 2. If I use 20 newtons of force on a 10 kilogram object, how fast is it going to accelerate? If that's the net force, you should see that's what? Both sides divide by 10. You should see that this acceleration would be 2 meters per second. 2 meters per second. So this is just a simple mathematical explanation of how mass and acceleration are proportional to the force that is required to move the object. So this is the only formula you need to know. F is equal to ma, and we could also play around with this formula and put it inside centripetal acceleration. And we can put it inside all of our other kinematic equations to do some very interesting things and solve real world problems. So this is what you need to know. Practice it. You will see it on the quick check. I hope you enjoy this. This is my favorite formula. I love Newton's laws. I hope you do too.